Deep learning is a subset of machine learning that involves training algorithms to recognize patterns and make decisions based on data. It is based on the concept of artificial neural networks, which are inspired by the structure and function of the human brain. Deep learning algorithms are designed to process large amounts of data, identify patterns, and make predictions or decisions based on the patterns. This is done through the use of artificial neural networks, which are composed of layers of interconnected nodes. Each node in a neural network performs a simple mathematical operation, and the output of one node is used as the input for the next node in the network. The layers in the network are trained to recognize different features of the input data, and the output of the network is a prediction or decision based on the patterns identified in the input data. Deep learning has been successful in various applications, such as image and speech recognition, natural language processing, and autonomous vehicles. It has enabled the development of systems that can learn, adapt, and make decisions on their own, without the need for explicit programming. Deep learning algorithms include convolutional neural networks, CNNs, recurrent neural networks, RNNs, and deep belief networks, DBNs. These algorithms have multiple layers of nodes, which enable them to process more complex data and make more accurate predictions. Neural networks are a key component of deep learning algorithms. They are composed of layers of interconnected nodes, which are modeled after the neurons in the human brain. The basic unit of a neural network is a node, which receives input from other nodes or external sources, performs a mathematical operation on the input, and produces an output. Nodes are arranged in layers, with each layer processing a different aspect of the input data. The input layer receives data from the external world, such as images, text, or sound. The output layer produces the final result, such as a classification or prediction. In between the input and output layers, there can be one or more hidden layers that process the input data to identify relevant features and patterns. Neural networks are trained using a process called backpropagation, where the error between the predicted output and the actual output is propagated backward through the layers of the network, and the weights of the connections between nodes are adjusted to minimize the error. There are various types of neural networks used in deep learning, including feed-forward neural networks, convolutional neural networks, and recurrent neural networks. Each type of network is suited for different types of tasks, such as image recognition, natural language processing, and time series analysis. Convolutional neural networks, CNNs, are a type of neural network commonly used in deep learning for image and video recognition, as well as other tasks involving spatial data. CNNs are designed to process data with a grid-like topology, such as images, by exploiting the spatial correlation of the data. CNNs are composed of multiple layers, including convolutional layers, pooling layers, and fully connected layers. In convolutional layers, the network performs a convolution operation on the input data using a set of filters or kernels. The output of each filter is a feature map that highlights a particular aspect of the input data, such as edges, textures, or shapes. In pooling layers, the network reduces the spatial size of the feature maps by downsampling, which helps to reduce the number of parameters and computational complexity of the network. In fully connected layers, the network performs a traditional neural network operation, where each neuron in the layer is connected to every neuron in the previous layer. CNN are trained using backpropagation, where the error between the predicted output and actual output is propagated backward through the layers of the network, and the weights of the connections between nodes are adjusted to minimize the error. CNNs have been successful in various applications, such as image and speech recognition, object detection, and autonomous vehicles. They have enabled the development of systems that can recognize and classify complex patterns in images and videos with high accuracy and speed. Recurrent neural networks, RNNs, are a type of neural network commonly used in deep learning for sequential data, such as time series data or natural language text. RNN are designed to process data with temporal dependencies, where the output at one time step depends on the output of previous time steps. RNN are composed of multiple layers, with each layer processing one time step of the input data. The output of each layer is passed as input to the next layer, creating a feedback loop that allows the network to learn from previous time steps. The basic unit of an RNN is a cell, which contains a hidden state that is updated at each time step based on the input and previous hidden state. The output of the cell is passed to the next time step as input, and the hidden state is used to capture the temporal dependencies of the input data. RNN are trained using backpropagation through time, where the error between the predicted output and actual output is propagated backward through the layers of the network, and the weights of the connections between nodes are adjusted to minimize the error. RNN have been successful in various applications, such as speech recognition, natural language processing, and time series analysis. They have enabled the development of systems that can generate text, translate languages, and predict future values based on past values. Deep learning has enabled the development of intelligent systems that can learn, adapt, and make decisions on their own, without the need for explicit programming. It has been successful in various applications, such as image and speech recognition, natural language processing, and autonomous vehicles. One of the most prominent applications of deep learning is image and speech recognition. Deep learning algorithms, such as convolutional neural networks, CNN, have achieved state-of-the-art performance on image recognition tasks, such as object detection and image classification. Similarly, recurrent neural networks, RNN, have been successful in speech recognition tasks, such as speech-to-text conversion. Another important application of deep learning is natural language processing, NLP. Deep learning algorithms, such as long short-term memory, LSTM, networks, have been successful in various NLP tasks, such as sentiment analysis, text classification, and named entity recognition. Deep learning has also enabled the development of autonomous vehicles, which can perceive and respond to their environment without human intervention. Deep learning algorithms, such as CNNs and RNNs, are used for tasks such as object detection, lane detection, and trajectory planning. In addition, deep learning has been used in various fields, such as healthcare, finance, and cybersecurity. For example, deep learning algorithms have been used to diagnose diseases from medical images, predict stock prices, and detect fraudulent transactions. Natural language processing, NLP, is a subfield of artificial intelligence that focuses on enabling computers to understand, interpret, and generate human language. It involves the development of algorithms and models that can analyze and manipulate natural language data, such as text, speech, and dialogue. NLP is used in various applications, such as chatbots, virtual assistants, sentiment analysis, text classification, and machine translation. It involves various tasks, such as syntactic analysis, semantic analysis, and discourse analysis. Syntactic analysis involves the study of the grammatical structure of sentences, such as parts of speech, sentence structure, and syntax. Semantic analysis involves the study of the meaning of words and their relationships, such as word sense disambiguation and named entity recognition. Discourse analysis involves the study of the structure and coherence of text, such as topic modeling and summarization. NLP algorithms and models are typically based on machine learning and deep learning techniques, such as convolutional neural networks, CNN, and recurrent neural networks, RNN. These algorithms and models are trained on large datasets of natural language data, such as corpora and annotated datasets, to learn patterns and relationships in the data. Natural language processing, NLP, has various applications in different fields, including healthcare, education, finance, and customer service. Sentiment analysis. Sentiment analysis involves the analysis of text data to determine the sentiment of the text, whether it is positive, negative, or neutral. It is used in various applications, such as social media monitoring, customer feedback analysis, and market research. Machine translation. Machine translation involves the automatic translation of text from one language to another. It is used in various applications, such as language learning, communication, and cross-border e-commerce. Chatbots and virtual assistants. Chatbots and virtual assistants are intelligent agents that can interact with users in natural language. They are used in various applications, such as customer service, personal assistance, and sales support. Named entity recognition. Named entity recognition, NER, involves the identification and classification of named entities and text into predefined categories, such as person, organization, location, and date. It is used in various applications, such as information extraction, document classification, and question answering. Text summarization. Text summarization involves the extraction of key information from text data and presenting it in a condensed form. It is used in various applications, such as news article summarization, document summarization, and email summarization. Text classification. Text classification involves the categorization of text into predefined categories or classes. It is used in various applications, such as sentiment analysis, topic modeling, and spam filtering. Computer vision is a subfield of artificial intelligence that teaches machines to interpret and understand visual data from the world around us. It has been an active area of research for many years and has made significant progress in recent years. Computer vision has a wide range of applications, from self-driving cars to facial recognition and medical image analysis. Computer vision involves processing visual data such as images and videos to extract useful information. This information can then be used to perform a variety of tasks, such as recognizing objects, detecting faces, and tracking movements. Image recognition is a fundamental task in computer vision. It involves identifying objects or patterns within an image. Machine learning algorithms are trained on large datasets of labeled images to recognize different objects and patterns. Object detection is a more complex task that involves identifying specific objects within an image and drawing bounding boxes around them. This task requires the use of advanced algorithms such as YOLO, you only look once, and RCNN, region-based convolutional neural networks.